Welcome, ladies and gentlemen. May I have your attention, please? Thank you. Raise your hand if you did not get a red mark for today, the 2nd of May. Okay, let's go ahead and get started. On today's quiz, you're going to have to be able to state the exact value for sine or cosine function of a particular angle that corresponds to one of our specials. And so while you will not be using your green sheets on the quiz, you'll be provided screenshots of your green sheet right there with values that you'll need. And so we'll give you the screenshot of your green sheet. But for now, on today's Bellwork, the key is deciding what special angle, 30 degrees, 45 degrees, 60 degrees, or 90 degrees, corresponds to the given angle measure 135. So what we're going to do is find a reference angle, right? The measure of the acute angle that connects the terminal side of the original with the nearest x-axis is the reference angle, and we use that to figure out the sine or cosine value. The only difference is we might have to add a negative, depending upon which quadrant the original angle lies. So let's go ahead and find 135 degrees. Just keep spinning, stop. So 135 degrees would be right here. 135 degrees is not on my green sheet, but by golly, I'll get a reference angle by considering the magnitude of that blue acute angle that connects 135 degrees to the nearest x-axis. Go ahead and tell the class, what's the magnitude of that reference angle? Mitch? The acute angle that connects it? The little one? For number 1 that you have written down? Absolutely, 45 degrees. Thank you. Perfect. And so the measure of the acute angle that connects 135 degrees to that nearest x-axis, like Mitch said, 180 degrees is 45 degrees. Good. Which means the sine, cosine, and tangent values for 135 are exactly the same values as the sine and cosine for 135 degrees. The only difference is we might have to add a negative. So everybody find on your green sheet, what's the cosine of 45 degrees? Nathan?
Negative root 2 over 2.
Yep, the cosine of 45 degrees is root 2 over 2, and Nathan knows that in quadrant 2, cosine values, which are based on x-coordinates, are negative. So he purposely added the negative sign already, so negative root 2 over 2 is absolutely correct. Raise your hand if you had that. So who had negative root 2 over 2? That's correct. Good job. Let's go ahead and add that negative sign if you didn't, and we'll practice now finding another reference angle. Everybody spin 330 degrees. Stop. So there's my 330 degrees of rotation. Now let's go ahead and find the reference angle. That's the magnitude of the acute angle here in blue that separates 330 degrees from the nearest x-axis, in this case 360 degrees. Go ahead and tell the class the reference angle when I call on you. Caitlin? 30 degrees. Good, thank you. So the sine of 330 degrees is the same exact magnitude as the sine of 30 degrees. Everybody find it on your green sheet. Be ready to tell the class when I call on you. So what's the sine of 30 degrees, Hans?
Sine of 30 degrees is 1/2.
Awesome. The only thing is we may or may not have to add a negative sign based on the quadrant in which my terminal side of the original angle, in this case 330 degrees, lies. Everybody look. Is sine based on the x-coordinate or y-coordinate? So sine based on x-coordinate or y-coordinate? Hannah? Y-coordinate. In quadrant 4, are y-coordinates positive or negative? Jacob?
Negative.
Negative. And so what do we need to do? We're going to go ahead and include a negative with our 1/2. Right? Absolutely. Good job. Thank you for your help. Raise your hand if you already had negative 1/2. Who else had negative 1/2 already? So the key is find the reference angle, state the ratio, add the negative if necessary, right? However, we don't always have to add the negative. If we had been in quadrant 2, sine value would have stayed positive, right? If we had been asking for the cosine of 330 degrees, cosine is based on x-coordinate, that would have stayed positive. And so you have to purposely decide whether or not you're going to add the negative based on the connection between sine and cosine and the x versus y coordinate. Awesome. Okay, so let's keep going. So this is a great question. What two angles in between 0 and 360 degrees have a value of sine of theta that's 0.77. This is not one of our exact specials from our green sheet. Instead, we're going to use our graphing calculator to determine the value of theta. In order to do that, we have to solve a trigonometric equation for an unknown angle measure, in this case theta. Well, we already know how to do that from quiz 1. What undoes the sine function? How would I get that missing unknown angle measure? Aaron?
Inverse sine.
Inverse sine, absolutely. And so if we know sine of theta is 0.77, I can get actual theta by taking the inverse sine of both sides. And so to find that on my calculator, I'll simply do the inverse sine of 0.77. Inverse sine of 0.77. Let's go ahead and do that on our calculator. Make sure we're in the appropriate mode. If we want our answer to be in degrees, make sure we're in degree mode. And on my home screen, I'll simply do inverse, the second sine, inverse sine of 0.77. Voila! That gives me 50.35 degrees. And so it looks like theta is about 50.35 degrees. Except for one problem. The problem asks for two angles in between 0 and 360 degrees. Are you kidding me? How am I going to get two angles? If I do inverse sine of 0.77 again, it's going to tell me 50.35 degrees. Enter. 50.35 degrees. Enter. 50.35 degrees. Our calculator is programmed to only give us one output every time we use the inverse sine, inverse cosine, or inverse tangent. But, however, I know there's two places on the unit circle in between 0 and 360 degrees where the value of sine is positive. In which quadrants is the value of sine positive? In which quadrants is the value of sine positive? Ian? In quadrants 1 and 2. And so we're looking for angles here, theta, that are in quadrants 1 and 2. Let's draw in that about 50 degrees, 50.35 degrees. So that's about right here. Ian tells us not only quadrant 1 has a value of sine that's positive, but also quadrant 2. So it looks like we've got two places where sine is going to be 0.77. These should be the same vertical displacement, that is vertical leg length in that right triangle, whose x-axis is the base. That should be the same vertical displacement, the same y-coordinate, the same value of sine in quadrant 1 and 2. How do we get them? Well, we already have one. We have our 50.35 degrees is right here. We need the same reference angle, but in quadrant 2, so 50.35 degrees taken away from 180 is 129.65. Is that right? 129.65. So we had to find that on our own, using our brains, saying, where else is sine a positive value? Oh, in quadrant 2, same magnitude reference angle, 180 minus would be my nearest x-axis. 180 minus 50 is going to be 129. So we need to add a second degree measure and about 129.65 degrees. And then that would be right here. So that would be blue matches blue. Well, that's awesome. Woo! That's a great question. It puts together our x versus y. It's kind of like numbers 13 through 16 on your homework that we'll talk about in a little bit together. All right, lastly, in relation to y equals sine of x, our parent function, our parent sine wave. Write the equation of a sinusoid whose graph is twice as tall and shifted down 4 units. We're going to complete that after our activity. We'll be able to do problems like this all day. So let's go ahead and take a look at our parent function, y equals sine of x. Twice as tall. Some of you got that for your activity stamps. We know we have a multiplier in front, so 2 times sine of x. And then shifted down 4 units, that would be the down 4 units would be that value of d. The center line would be moved up or down d units. In this case, down for negative 4 units. And here's my graph. We can see that on the window negative 2 pi to positive 2 pi, the red transform function is twice as tall. Its wave height is twice that of the parent function, 1 sine x in blue. And it's been shifted with the center line down 4 units. And you're going to deal with that in your activity. Your homework after the quiz will be problems like this. We'll be finishing that activity so we can do problems like this. So we're not going to spend more time on it right now. We're going to hold off on number 4. And we're going to instead direct our attention to our quiz 2 review. We'll have a nice little review together on your note sheet. That will help us answer numbers 13 through 16 on your quiz number 2 review homework. Number 8, we'll turn that in out of 32. No reading questions, so it'll be out of 4. Then we're going to take your quiz number 2. When you're done with your quiz and turn it in face down in the front, you're going to use the rest of the time to work on assignment number 9, which is complete the activity for stamps. There's no other book work, there's no other worksheet. You need to complete the activity, and then you'll get stamps next class. Questions about what today's going to look like? Let's get going so you have plenty of time for your quiz. Here we go. If there's one thing you've gotten out of our rotation activity, our unit circle, it's that the x-coordinate and y-coordinate are connected to those trig values, sine or cosine. The question is which or which. So if we spin theta degrees in either direction, the x-coordinate of this point on the unit circle is given by which function? Sine or cosine. Get ready, and then tell the class when I call on you. What gives us the x-coordinate? What gives us the x-coordinate? Jarrett? Cosine, absolutely. So no matter how far I spin or in which direction, I know the cosine of theta will give us the x-coordinate. And so if you're on your quiz and you're told that you spun, 196 degrees, what's the x-coordinate? You'd simply do cosine of 196 degrees, enter, and it would tell you the x-coordinate. What's the y-coordinate given by after spinning theta degrees? Mark?
Sine.
The sine of theta. And so sine of theta would be the y-coordinate. In this way, we can make a connection between x and y coordinates and find them, right, depending upon what information we're given. And so we'll go backwards a little bit. In which quadrant is sine negative? In which quadrant is sine negative then, if sine is connected to the y-coordinate? Get ready. In which quadrant is sine negative? Mackenzie?
3 and 4.
Sine is negative in 3 and 4, right? Sine is negative in 3 and 4. Thank you. Why is sine negative in quadrants 3 and 4? What's the connection there? Rachel?
It's below the y-axis, or the x-axis.
Below the x-axis, right, where y-coordinates are negative. And so because sine is based on the y-coordinates, and y-coordinates are negative in quadrants 3 and 4, the values of sine are negative in quadrants 3 and 4. Good, thank you guys. In which quadrants is cosine? Is cosine negative? Get ready. So in which quadrants is cosine negative? Will? 2 and 3 is correct. And why is cosine negative in 2 and 3? Why is cosine negative in 2 and 3? Taylor?
It's to the left or y-axis.
Absolutely, right? Quadrants 2 and 3 are to the left of the origin, where my directed horizontal displacement, that is the x coordinates of any point in the unit circle, are negative in quadrants 2 and 3. Nice job. Name another angle between 0 and 360 where the cosine of theta equals the cosine of 160. Well, recall cosine, right? Cosine is directed horizontal displacement. That's like x coordinate. So where else would cosine be negative? Well, exactly the same magnitude, x coordinate, right, as this triangle. But my angle would have to be now not in quadrant 2, but in quadrant 3. So I could determine a reference angle. It looks like we're 20 degrees off the horizontal 180, which means that this angle measure must be 20 degrees. And so my final answer, theta, would also be not 160, but 200. So it looks like 200 degrees would have a value of cosine. Cosine of 200 must equal cosine of 160 because they're the same directed horizontal displacement from the origin. Their x coordinates must be the same. Does that make sense? Let's try another. This time, though, let's do a sine question. Name another angle between 0 and 360 where the sine of theta is equivalent to sine of 280. So 280 is down here. Its directed vertical displacement would be the sine value. Well, where else would that happen? Well, that would also happen at this point. And So it looks like if I could figure out the degree measure of that point, it looks like we're 80 degrees off of the horizontal, so 80 degrees off of 180 would be 260, is that right? 260? So it looks like 260 degrees would have a value of sine that matches 280 degrees. Nice. Questions about 4 and 5? Those are good questions because they tie together the x versus y coordinate as well as the signs, that is positive and negative, of the trig function. All right? Then let's go ahead and complete a couple of conversions. You'll also have to do some conversions on your quiz. Everybody have your chart? Cool. Let's go 4/9 to degrees. Recall we can multiply 4/9 revolutions by starting with my indicated unit and then multiplying by an identity whose sole purpose is to get rid of the label we don't want and move to the label we do want. Go ahead and tell the class the identity that relates degrees and revolutions. There's how many degrees and how many revolutions? Blake?
360 degrees and 1 revolution.
Absolutely. So 360 degrees corresponds to 1 revolution. We'll get rid of the label I don't want, go to the label I do want, and I can go straight across and then math frac in order to keep it exact. So here we go. 4 times 360 divided by 9. Enter. Math frac not needed because it's 160 degrees. Hey, that's cool. Awesome. Velocity. 4/9 revolutions to radians exact. All right, so we need a conversion fraction that gets rid of revolutions and goes to radians. Hey, I know that in 1 full revolution of a circle, there are 2 pi radians exactly because of my circumference formula. If each radius of length on the outside of a circle corresponds to 1 radian of spin on the inside, then my circumference formula told me that c equals 2 pi r. Therefore, there must be 2 pi radians of spin on the inside in order to get that 2 pi radius length on the outside. That's pretty sweet. If I want exact, recall I'm going to leave off the pi in my calculator. So everybody, when we go to keep this exact in math frag, I'm going to leave out of that pi. In this case, I can just go straight across and then add it in because the numbers aren't big. I would get 4 times 2 pi is 8 pi over 9 is 8 pi over 9. However, for those of you on your quiz where it's not working out so nicely, you could do 4 times 2 divided by 9. And then you could do math frac, enter, and then put the pi back in on top manually. So if you are in a bind and you're using your calculator, then you can always change it back into a fraction if you leave the pi out of your calculations. In any case, we generate 8 pi over 9 radians for the exact, and again, we can simply enter that in my calculator with the pi in order to get the approximate. So the approximate, I just enter 8 pi over 9 and get the approximate. It looks like I have 2.79 about radians. Awesome. Let's go 2 pi over 5 radians to revolutions. So we know that we'll multiply by a conversion fraction whose sole purpose is getting rid of the label that I don't want, in this case radians, and moving towards the label I do want, in this case revolutions. So we saw that in 1 revolution there were exactly 2 pi radians. Again, we'll multiply straight across, divide by every quantity on the bottom. If you're going to do it in your calculator, please divide by the quantity 5 times 2 pi, so you're not just dividing by 5 and then multiplying by 2 pi on top inadvertently. You want to put parentheses around that. But we can see here that again the 2 pi's will reduce. 2 pi divided by 2 pi is 1, so I get 1/5 of a revolution. I get 1/5 of a revolution. And you can verify that in your calculator as well. 2 pi over 5 exact to degrees. Again, start with the thing that I don't want? I want to get rid of radians. I want to go to degrees. And in 360 degrees, there are exactly 2 pi radians. Again, the 2 pi's will cancel out in this case. And I'm going to be left with 360 divided by 5. Or I can practice with my calculator. 2 pi times 360. I'm going to divide by parentheses so I don't mess up. 5 times 2 pi, close parentheses. Voila! I get 72 degrees. And recall the approximate. If I'm in radians to approximate, I just enter it with the pi in my calculator, and that's it. And so I'd simply do 2 pi over 5, enter, and that's approximately 1.26 radians. And 1 to go. Let's go ahead and go degrees now to revolutions. So degrees to revolutions, multiply my conversion, get rid of degrees, go to revolutions. I know in 1 full revolution, that corresponds to exactly 360 degrees. We can go ahead and get an exact answer by doing math frac. Keep in mind that we will have a negative, and that's okay. We would just spin in the other direction. So I get negative 150 times 1 divided by 360. Enter. Math frac. Voila! Negative 5/12 of a revolution. So I get negative 5/12 of a revolution. And degrees to radian is exact. By golly, we can multiply by a conversion. This time, I want to go to radians. So I know in 360 degrees, that corresponds to exactly 2 pi radians of rotation. This is the one where I will use, right, I'm going to leave that pi out of my calculator. Everybody do it. Because you have to do it exact on your quiz. So everybody do it. Make sure you can do it without the pi in there, right? To make sure you can get exact. One of the questions on your conversions has you to do exactly this. So I've got negative 150 times 2. I'm going to leave the pi out. Divided by 360, math frac. Enter, then I'm going to manually put it back in. I get negative 5 pi over 6. So I get negative 5 pi over 6. For my exact radians. And again, as an approximation, I simply put the pi back into my calculator. And I get negative 5 pi over 6 radians is about negative 2.62 radians. That's pretty sweet. And what questions do you guys have about your conversions? So portion of your quiz will be conversions. Okay, then we're going to now play your third favorite game. Yes, that's right. Your third favorite game, in which quadrants is. So I'm thinking of a quadrant where cosine is positive, but sine is negative. Everybody think. Cosine is positive, but sine is negative. Where am I? I'll call on you to share with the class. So get ready. Thinking of a quadrant where cosine is positive, but sine is negative. You're gonna.
4.
Quadrant 4 is correct. Good job. Raise your hand if you're gonna say quadrant 4, even though I didn't call you, but I was gonna call on you. Okay. All right. I see your game. Ready? I'm thinking of a quadrant where sine is positive and cosine is negative. Get ready. Sine is positive and cosine is negative. Where am I? Carolyn? Quadrant 2. Raise your hand if you think quadrant 2. Quadrant 2. You're correct. Good job. I am thinking of a quadrant where both sine and cosine are negative. Both sine and cosine are negative. Where am I? Maya?
3.
You are correct. Quadrant 3. Good job. So we're feeling good about sine, cosine? Yes, yes? Okay. Awesome. Then let's go ahead and take a look at our quiz number 2. We will look at 13 through 16 briefly together. Give yourself credit just based on completion, right? Not on accuracy, but out of 32 problems, how many did you do? Even if they're wrong, divide, enter, multiply by 4, and no reading question today, guys. So nobody should have a 5 for your infinite campus score. Your maximum infinite campus score at the top of quiz number 2 review worksheet should be round to the nearest half point 04. Do make sure that your name is on top though, so that you can get credit in infinite campus. I'm going to go ahead and pause the recording now as we check our answers. In just a minute, ladies and gentlemen, I'm going to distribute the quiz, right, so that you can show us what you know about sine and cosine values, the unit circle, and conversions. But first, I ask you to direct your attention at the front slide after the quiz. You're going to work to complete activity 4 at moves. You'll need your extra handout sheet. You can work side by side, extra handout and activity, but you're not going to work in your cooperative learning groups because different people will finish at different times. So once again, this is your only assignment. You'll work on activity 4 individually without talking. You need to get stamps. Part 2, number 6, most of you already got. Part 3, number 10, lots of you got. Still need Part 3, number 17 for a lot of you. And Part 4, 3E, 5D, and I'll put that up on the front whiteboard so that you can see if you haven't circled them already. Next class period, we'll issue stamps. That is your assignment, no bookwork. Then we're going to continue graphing with our transform sine and cosine curves. I'm looking forward to that, but there's no other assignment than the activity. What questions do you have about what the rest of today's class period is going to look like? Okay, I'm going to go ahead and pause the recording and upload it to our Moodle site.